Again, I know this is not an easy process. That's why today and Friday we're going to spend time on it. And I think actually the next thing after this, we'll see another technique that builds on this. Okay. So I understand this is not easy. Okay. Oh, I can't see that. All right, let me get it back up. All right. Any questions though? Also, what I did was I posted on Blackboard questions that are in the textbook, the 3rd edition and the 4th edition. You know, questions you can do for practice. You don't have to do them, but you can. I posted them on Blackboard. If you can't find it, just let me know. But I want to do another example. So other questions? Or? Okay. So here's another one. Again, this has 4 terms, right? So because of that, you really want to try factor by grouping. So 4 terms, factor by grouping. And again, what you really want to do in the beginning is try and find the GCF of the entire polynomial. That's what you want to find. Okay, well, there's a non-zero constant term here, right? There's no x here. So we can take m here to be 0. Again, there's no x's here, so we take m to be 0. Now, we could list the factors of 2, 4, and 8. You could do that. However, since 2 itself, okay, is a factor, since 2 itself is a factor of the other numbers, you know, the other coefficients, and the constant term. 2 is a factor of the coefficients and the constant term. It turns out then that 2 is the greatest common factor of the coefficients and the constant term. And again, if you were to list the factors, you would be able to see that. I mean, the factors of 2 are just 1 and 2. The factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, 4, and 8. So we get b has to be 2. So the GCF of this is 2. Once we know what it is, we factor it out, right? We put it in front, we divide. Okay, that's great. And how do we divide? We divide into each term here, like so. Okay. And what happens when you divide? The first quotient, the 2's cancel. Let me actually draw it in. Right here, the 2's are going to cancel. So you're left with x cubed. The 4 over 2, right? You get 2. 2 down here goes away. So we're left with 2x squared for the second term. This term here, 2 is gone. This 4 becomes a 2. That's how we get that. Finally, 8 over 2, right? 2's gone. That becomes a 4. So we get 4 here. Okay. So this is what we have now. Okay, good. So now we have to factor this.
Can you go back? Sorry.
That's okay. I mean, I did email everyone the notes, so I think I did. Yeah, I'm pretty sure I did, but okay.
Thanks.
You're welcome. Okay, yeah, again, if I go too fast, don't be afraid to say something. You know, everyone, I mean. So from here, we have two groups. We can form two groups of two, right? Four terms. So we use parentheses to make two groups of two. Here we actually have the addition between the second and third term. You'll actually, I think it's in the next example, you'll see what happens if we don't. Okay. But now we have to handle each of these terms. And what do? We factor each one individually. Okay, so from the first group, we're going to get x cubed minus 2x squared. That's the first group, right? Okay, so let's factor it. Well, we can see that the smallest exponent of x is 2. Right? The smallest exponent of x is 2. So m is 2. The coefficient here is 1. And as we already know, if a coefficient is 1, then your b has to be 1 in the GCF. In other words, the greatest common factor among the coefficients here has to be 1. So that b times x to the m, that GCF, is just 1 times x squared, which is x squared. So then we have this GCF. So now we got to take it out. We factor it out. We have x cubed minus 2x squared. That's going to become x squared times, again, you have to divide to see what's left over. And when you divide into each term like this. Okay, you divide into each term. And what happens when you do that? Well, you're going to get x squared times x cubed over x squared. That's x, right? 2x squared over x squared, that's just 2. So we get this. And that's what we get. Now that's from the first group. What about the second group? Well, let's see. 2x minus 4. Well, we can see that the smallest exponent of x, that's 0. Right? You know, there's a non-zero constant term. So we can't factor out x from every term. That is, the GCF cannot have x in it. So m is 0. For 2 and 4, 2 is a factor of 4. So 2 must be the greatest common factor of 2 and 4. Again, you could list the factors of 2 and 4 if you want. You would see 2 is the greatest common factor among 2 and 4. So the GCF of this thing must be 2. You know, 2 times x to the 0, which is just 2. So what do? Factor it out. GCF is 2. Factor it out. We have 2 times 2x minus 4 over 2, which is 2 times 2x over 2 minus 4 over 2. 2x over 2 minus 4 over 2. And what happens when we do this? The 2's cancel. We get x. 4 over 2 is 2. So we get this. Now again, from each group, when we factor them, what's left in parentheses is the same, which is x minus 2 here. That's good. You know, you want the group you want, after doing this GCF stuff, what's in parentheses here to be the same. So now we have to take that out, and that's what I'm doing. What's in parentheses, we take that out. Okay. And how do you know what's left over? You divide. You divide. Once you divide into each term. That's what I'm doing down here. And then, of course, you cancel. And you're left with x minus 2, x squared plus 2. And that's what we get here. Okay, so the original polynomial, well, not the original, but this polynomial we get here. The very one we started with here, well, we took out 2 to get this one, and this one we just factored. So the final answer is this. 2 times x minus 2 times x squared plus 2. That's what we get. That's what we get. Good.
Could you just re-explain that?
What?
Could you just re-explain that? I'm sorry.
Oh, sure. So this is what we just factored here. You know, if you go back, this is what we just factored, right? That was this. The original polynomial, we got to be 2 times this here. So I just put the 2 in front of what we just got, and that's the factorization of the original polynomial. You know, the one we started with.
Okay, that makes sense.
Yeah.
Thank you.
Good, good. You're welcome. Good question.
I have a question about, like, I usually get lost in like on the top where it's like x to the third minus 2x squared plus 2x minus 4th. Like after it, like, what did you do to get x minus 2? Did you factor?
How did I get from here to here?
Yeah.
That was what I did on these slides. I took out the GCF from each group here. Remember how we had this polynomial?
Yeah, I understand that part, just the part.
And then we got these groups, right?
Yeah.
And then from each group here, we found its GCF, and we factored that out.
Yep.
And that's how we got this.
Yeah.
And same thing down here. We find its GCF, which is 2, and we got this.
Mm-hmm.
And so all I did was I substituted for those groups, like for the first group here, right?
Yeah.
I put x squared times x minus 2.
Mm-hmm.
Okay. And then from this one here, I put 2 times x minus 2.
Oh, I see it. Okay.
Okay.
All right.
Awesome.
Thanks.
Good question. Okay. Are there any other questions? No, the questions are good. So I know this isn't easy. Believe me, I completely understand. So I completely understand. Okay. And it's kind of thing, I mean, really, this is the kind of thing I guess that takes